Hey guys, welcome to a video where we're going to try and move the code of this method to a slightly more object-oriented approach. Now, what I mean by that, and the list of the drawbacks of the current design can be found in allaroundjava blog, for which you can find the link in the description, so definitely check it out. And what I mean by moving to object orientation is, for this particular example, I'm going to try and move the decisions closer to where the data is. Now, this class is a service class with one method. It follows an Anemic model, so something which is very much procedural. The classes passed as parameters are, in fact, data structures exposing their internals via getters. And this method exploits that very much. It uses all the information that the structures expose to calculate what it needs, basically. And this is something that I see very often, and this type of design causes a lot of issues. It's a little hard to understand, maybe not very hard, but it takes a moment for you to read through all this code to understand what it does. It is quite tricky to test. Again, the method is short, so maybe not too hard, but there's a few for loops and a few if statements, so it definitely requires some sweat to cover all the cases. It's quite difficult to extend. If we'd like to add a new item from which we calculate the salary, we'd need to add code to this class and this method. So this is a cause very often of code duplication and a reason for spaghetti code and spaghetti methods, because those tend to grow very much. Now, if you take a look at the method itself, it accepts two parameters. There's a list of working days and trainings. And what it will do is it will try to calculate the total salary based on the hours contained in those working days and trainings. It will loop over the working days, take the regular hours and the overtime, multiply that by some factor, do the same with trainings. If the training is outside of residence, it will add a little bonus onto that. Now, if we're in the December month, there will be a little bonus related to this one as well. So that's basically what this method does. Now, the first thing that I'm going to do is I'm going to refactor the loops into functions. They're pretty independent from each other, so I can easily do that using Control-Alt-M. I'll just give it a meaningful name. The first function deals with calculating working day salary. Now, the second one deals with calculating the training salary. And this one just deals with the extra bonus. So let's give it that name. Let's keep the original signature for now. Now I'm going to get rid of the result variable in each of the method declarations. They don't need to care about the value that is passed to them. They'll just calculate whatever they're responsible for and return the value back. So I'll just do that by introducing this local variable here and get rid of the parameter. For this one, I can just return 150 if it's December and 0 otherwise. Safely delete the parameter with Alt-Delete. And now I can get rid of the result local variable in the top level calculate salary function just by chaining the calls of all those three functions. That's basically what the Big Decimal API allows me to do. Okay, now let's pause for a second and take a look at the calculate salary method. This method's body got really simple. All it does now is take the working day salary, add the training salary, and add a bonus on top of that. Now, if you remember from the start, I told you that the calculate salary method was a little complicated and it was somewhat difficult to understand where the bug was because it could be anywhere within the method body. Now, the first big benefit of our refactoring is that the calculate salary method's body got really simple. Now, if you look at it, you can be almost sure that if there is a bug anywhere, it's most likely not here. Okay, great. Now let's take a moment to take a closer look at the functions we have extracted. The getWorkingDaySalary method operates only on the data that comes from outside of this class. If you look at this method, I'm not using any of the fields from the salary service method. The only thing I'm doing is I'm looping over the list of working days, looking inside of each of the working days, getting the hours and the hours overtime, and applying some arithmetics on top of that. Now, if you look at the working day class, it's just a very simple data structure carrying the hours and hours overtime and exposing that data via getters. Now, what I said at the beginning is that with this refactoring, I want to move the decisions closer to where the data is. Now, if you look at the salary service actually has to look inside of other classes to do its job. But if you look into the working day class, the working day class has enough knowledge to actually be able to calculate the total salary coming from that working day. So inside of the salary service, what I'm going to do is I'm going to say, hey, working day, give me the wisdom you've got encapsulated inside of you. I don't want to care about the calculation. You've got enough powers to do that yourself. Just give me whatever the final result is. Okay, so let's do just that. What I will want to do is I want to ask the working day to give me the total salary. There'll have to be a public function, and I'll move the code that does the job to the working day class now. Do a little bit of cleanup. I can use the private fields now. So I'll use hours. I'll add the overtime to that, and I can use the overtime private field again. And the next thing I have to move is the constants. They should be private, by the way, so sorry about this. There's no need to expose them as public constants. But if you think about where things should be, those two values contribute to the arithmetics related to the working day salary. So they probably should be in the working day class. This probably means we're on the right track. Now going back to the working day salary method, I can get rid of the code that I moved. And I can get rid of the getters as well. They're not used anywhere anymore. And now my working day became a class. It's no longer a data structure. It has a behavior. It can calculate the salary for me. And that's one of the properties of object-oriented programming. Objects encapsulate the data that is contained inside of them and expose behavior. Okay, let's do the same thing to the training salary method. I'll want to ask training to give me the total salary. Create the method. It'll have to be public. I'll move the code that does the job. Do a little bit of cleanup. I can use the local field now, and an if statement as well, and return the results. Great. Let's get rid of the code that I moved and get rid of the getters because they're not used anywhere anymore. Now going back to salary service class, I can do a little bit more to make our methods look a little nicer. I'll just apply stream processing instead of the for loops, and I'll use the reduce operation on the stream to give me the total salary contained in all the working days and trainings. We're long after Java 8, so I can definitely do that now. And that concludes the most important step of the refactoring, which is moving the methods closer to the classes who can make the decision based on their fields rather than somebody else's data. But that's not everything. We can definitely do a little bit more. If you take a look at the trainings and working day classes, their API is very similar. They both expose the same getTotalSalary method, which returns big decimal. So why don't we just go ahead and extract interface. Okay, let me call it a billable day. That will capture both the trainings and working days. getTotalSalary method is the one that I want to use as an interface method. And I'll add that to the working day now. And now going back to our calculate salary method in the salary service, this used to accept two lists of working days and trainings, and I can play with that a little bit and ask it to accept two lists of billable days, which will help us simplify the class a little bit more. If you look at get training salary and get working day salary functions, they're exactly the same. So I can just use one of them and get rid of the other. All right, and this one lighted gray, so I can just get rid of it. And as a result, our salary service class gotten a little simpler again. The calculate salary method is very simple and linear, and the get salary method is also very simple code. There's no branching over ifs. The code is just very easy to understand. But there's even more that we can do. It is a good practice to encapsulate a collection into a class of its own, just because you can give it a behavior. And that's what I'm going to do next. I'll call this new class billable days, which is basically a plural from a billable day. And that will hold a collection of my billable day instances. And that's how I will want to use it. So I'll just say billable days, give me the total salary, and add the bonus. Okay, so let's just go ahead and create the billable days class, put it in the data package, and create the get total salary method there. That will return big decimal, and it will have to be public as well. And I'll just copy over the code from the get salary, because that already works on a collection. I'll just add it here. This is my collection that the billable days encapsulate. Let me just make it private final. Accept it as constructor. And that's our billable days class. Really simple. And now I can just get rid of this. And I can safely delete the working days parameter, Alt delete, and I'll delete the trainings parameter. And the only thing this function now accepts is the billable days. If you can allow yourself for such a function declaration change, that's definitely beneficial. Our calculate salary method has gotten a little simpler again. I can get rid of the get salary method that is not used anymore, because I just moved that code away from this class. And now the only thing I have to take care of is the get bonus function, which is kind of complicated in the sense that it makes the whole salary service class a little hard to test. The get bonus function will only return a value if the current month is December. Now, we want to make sure that our unit tests are as deterministic as possible, and with the current approach, it basically won't work. So I'll use this very cool refactoring that is called the extract method as method object. So I'll just hit Ctrl-Alt-Shift-T, refactor this, replace method with method object. Let's call it a bonus class. And that function can just be called the get instead of invoke. And that's how we make sure that this code, the code of the get bonus function, lands in object of its own, which I can now move away from the salary service class to be a top level object. And I'll make sure the bonus object is passed as a constructor parameter to the salary service class, which will make it a lot easier to test. Let me just make it private final and pass it as a constructor param. And there we go. Okay, let's take a moment to summarize what we really did here. We've started from a point where salary service class followed an Anemic model, which is actually a very common one. You can find it in several tutorials, and it's also an approach in which probably all of us coded at some point. The code of the service that we refactor was somewhat complicated. It definitely took a moment to read through and understand what it did. And as a first step, we've extracted functions. They were responsible for calculating the working day and training salaries, and we found them a new home. When we found them a new home, we actually moved them into a place where they actually belonged. The same code started residing in a class which could make the same decision but based on its own class fields rather than somebody else's data. Thanks to that, we could encapsulate the data contained in working day and training classes, and they've actually became objects rather than data structures now. The code turned more object-oriented rather than procedural. The salary service code became much simpler, much shorter, and much easier to understand. All of the classes, the old ones that already resided there and the new ones, as a result of our refactoring, became much easier to test. And the code is of course easier to extend. In order for us to add a new billable day, we only have to subclass it. We don't need to change any of the existing code, which is great if the code is already in production. Thanks ever so much for watching. If you've reached this point, you've been really, really brave. Let me know in the comments whether you liked it, whether it was easy to understand, And for some more similar material, go to allaroundjava blog.